Hello, my name's Kevin Large and I shall be your instructor for today's video. I'd like to welcome you to the second in a series of videos in which we're using Cisco's Packet Tracer tool to design and configure an evolving network. This network is going to get more complicated with each video as we progress through the series. This is the second video in the series and it will be looking at trunk links, the VLAN trunking protocol, VLANs themselves, and also subinterfaces. So we'll be covering the creation of a trunk link. And what is a trunk link? Well, a trunk link carries all the VLANs. Basically you have access links, and an access link is in one VLAN. It's in one VLAN only, unless of course you have a voice VLAN as well. You can have a voice and a data VLAN, but typically an access link is in one VLAN only. And then you have the trunk link, and the trunk link carries all the VLANs, generally between switches or between a switch and a router. We'll look at using VTP. What's VTP? Well, VTP is VLAN Trunking Protocol. As you probably know by now, there are hundreds if not thousands of protocols. VLAN Trunking Protocol, this allows us to create a VLAN on one switch, the VTP server, and it will automatically propagate the information between the switches along the trunk links, allowing the switches to replicate the VLANs. So we create the VLANs once on the VTP server and they will magically appear on the VTP client switches. We'll look at creating the VLANs themselves. This is extremely easy to do, and naming VLANs. We'll look at adding switch ports to VLANs, because although VTP allows you to create the VLANs on one switch, the VTP server, and they'll be replicated on the VTP client switches that are connected to that server via the trunk links, it doesn't of course put ports in the VLANs, so you still have to manually put the ports in the VLANs. Okay, so we're going to add switch ports to VLANs, and then we're going to look at creating subinterfaces on the router, and we're going to continue from the network that we finished configuring in Lab 1, which was the Devices and Configure and Connections lab. Okay, so moving forward, looking at that lab, this is where we left off in the first video. We have 3 layer 2 switches, a couple of routers. One is our company router, the other one is off in the internet somewhere. We've got a corporate network on the other side of that router. If this was really the internet, of course we'd have a sort of cloud here, we wouldn't know what was going on in the middle there. We can make it more complicated as we move along. But we've got a wireless access point over here. Actually, if we've got a wireless access point, we should have really put a laptop there, shouldn't we? Do that now before I forget. Let's click on End Devices, select a generic laptop, and pop a generic laptop onto the board there. Okay, this laptop will be living in VLAN 10, the sales VLAN. One of the 200 hosts that are in VLAN 10. Okay, it would pay, if you've not seen it, to have a little look through the first video just so you can see how we built this network up and how it's addressed. Okay, so this is the master address for our company network, 172.16.10.0/23. We've broken that down into 4 subnets. That's the 172.16.10.0 subnet with a /24 mask. 200 hosts in that subnet. We've got the 172.16.11.0 subnet with a /26 mask with 50 hosts. We've got the 172.16.11.64 subnet with a /27 mask with 25 hosts. And then finally we've got a little corporate intranet server farm, I suppose you might call it, VLAN 40 servers, which has just 10 hosts, 172.16.11.96 with a /28 mask. Okay, looking at that then, we now need to move on, and the very first thing we're going to do is we're going to set these links between the switches up as trunk links, and also the link between the switch and the router. Okay, so I'm going to label it first. I'm going to make sure I know that these need to be trunk links. So that will be a trunk link, and so will this. And a trunk link will carry all the VLAN information, all the VLANs that are active on the switch. Yes, you can actually remove VLANs from trunk links, but we're not going to go into that level of detail at the moment. So all the active VLANs on the switch will end up in the trunk links that we're configuring. Okay, so we'll create these as trunk links. We'll configure two of the switches. We'll take the middle one and the right hand switch and configure them to be VTP clients. We'll leave the switch on the left hand side here as the VTP server, and then when we create our VLANs on this switch, they'll automatically be propagated across to the client switches. So, golden piece of information here. Every VLAN should be a subnet. When you're talking about layer 2 switching like this, each VLAN is a subnet, each subnet is a VLAN. There's a one-to-one mapping here. VLAN 10 is the 172.16.10.0 subnet. VLAN 20 is the 172.16.11.0 subnet, and so on. So we've got a one-to-one mapping between VLAN and subnet. Okay, so without further ado, let's create the trunk links first. Okay, so we'll go into the first switch. And you can see, there you got 24 port switch, nice Cisco 2950/24 fast Ethernet ports, looking at the front of the switch. We'll go to the CLI tab, so we'll do this properly, we'll do it from the command line. Okay, and if you look very closely, you'll notice that the host name says switch. This is the default host name. It effectively means somebody hasn't really set a host name on here, so we'll create a host name. That's the first thing we'll do. I'll do that by typing enable. Let me just get the caps lock off. Enable. Now I could shorten enable, and we will start using abbreviations in a little while. The Cisco iOS command line will accept abbreviations as long as you don't abbreviate things so much that they're ambiguous. So I'm going to type configure terminal. In fact, what I'm going to do, I'm going to type CONF and hit the tab key on the keyboard. Okay, CONF is enough of the command for it to know what I'm trying to do. I'm trying to type the command configure. So CONF tab will finish the command for me. T tab, configure terminal. I want to configure from the terminal. Okay, I'll just prove something to you. If I type exit now, I could type conf T, and that would do exactly the same thing. So abbreviations, no problem whatsoever. Saves a lot of typing. How do you think you configure a host name? Well, host name. It's as simple as that. Host name SW1. Okay. It's a very good thing to do. It's good practice to configure host names on your devices. That's one of the very first things you should do. Otherwise it's so easy to end up configuring a device which is not the device you think you're configuring. You end up tapping away, putting a load of commands in, and then you find out later on that you've put those commands on completely the wrong device because everything's called switch or router. Okay, so we're now in SW1, the left hand switch. It's been given a host name, and we need to create some trunk links. Now the trunk links on this switch, if I click on the background and hover over the little light bulb on the end of the link, I can see Fast Ethernet 023 and Fast Ethernet 024. Both need to be configured as trunk links. Okay, here we go then. Interface. Now there's a little shortcut we can use here. Notice how I typed INT and hit tab. That was interface. If I hit the R key and hit tab, I get interface range. The FA and hit tab, Fast Ethernet. The tab is your friend, saves so much typing. Interface range Fast Ethernet 0/23 space hyphen space 24. Those spaces either side of the hyphen are important. Okay, boom. That's dropped us into config if range. I'm sure you can guess what that's done. Anything we type now will actually apply to both Fast Ethernet 023 and 024. Okay, so we can do both interfaces at once. The command to turn it into a trunk link, int tab, sorry, not int tab, switch port mode trunk. Straightforward, isn't it? I want that switch port, or in this case those two switch ports, to be in trunking mode. So switch port mode trunk. Okay. If you look very closely, it's actually brought the interface down between the switches. That one was up, but it's brought it down in order to switch the mode over. The one up to the router isn't on anyway because the router side of that link is shut down. But the reason why we get the orange light is because of something called spanning tree protocol. It's designed to stop loops from occurring on a layer 2 network. On a layer 2 network, in the frame header, there is no time to live field. There's no TTL. So the frame can go round and round in a loop forever. So if you accidentally connect two switches together with two crossover cables, creating a loop, if spanning tree was not running, you'd have a very, very big problem because that frame will go around forever. Layer 3, the IP packet in the header has a TTL field, a time to live, so that will normally stop that from happening. The time to live is decreased every time it passes through a router. When it hits 0, the packet's dropped. So switches, not the same. Okay, so we have created a trunk link on that switch. We need to go on to the next switch and do the same thing. I'll speed up a little bit now. Okay, so we'll go into the command line and the use of abbreviations. EN conft for configure terminal, HOS, hit tab, SW2, switch 2. I know where I am now. On that switch, which interfaces? I think it's the same. Fast Ethernet 024 and Fast Ethernet 023. Okay, precisely the same. Int range FA 0/23 space 24. SWI tab M tab T tab. I love that tab key. Switch port mode trunk. Fantastic. Right. And what we'll do is we'll do a Control Z. What does Control Z do? Well, Control Z, doesn't matter how far into the configuration you are, how many modes you've gone into the configuration, it'll always jump you all the way back to what's known as privileged exec mode, where you have the little hash key. And I'm going to type WR as well. Now that's the old command. That's short for write terminal. The new command is copy running config startup config, but you can't abbreviate that quite so easily. What does copy running config startup config do? It copies the running config, the configuration running in RAM, that's the one we're using, into the startup configuration, which is non-volatile RAM. It effectively saves the configuration on your switch or router, but I still like to use the old command because you can just type WR and it does it. Okay, let's move on to the third switch. And we'll type enable and conft and HOS SW3, boom boom, and then we'll do INT R. Now hold on. How many trunk links have we got on here? Only the one. Only one trunk link. Fast Ethernet 024. We don't really need the range then, do we? We can just say interface Fast Ethernet 0/24. Switch port mode trunk. Done. Right. Didn't get a warning that time about the trunk going up and down, because to be honest with you, what actually happened is it realised the other side was a trunk link and it had made itself a trunk link anyway, but we'll talk about that later on. It's not necessarily a good thing. We will set it up later video so as it doesn't do that sort of behaviour where it automatically becomes a trunk link if the other side's a trunk. Okay, so we've got trunk links between the switches. That's excellent. What we'll do is we'll go into the server switch and we'll do a Control Z. Brings us back to privileged exec mode, a WR. I'll tell you what, just to show you what the new command looks like. Copy running config, startup config. In fact, it's been that command for a very long time. In that case, it asks you what to call the destination file name, square brackets, that's the default, startup config, which is what you really want to call it. Hit OK, enter. But you see, how long does that take compared to WR? Another little shortcut, if you hit the up arrow, it puts previous commands in. If you hit the down arrow, Goes the other way through previous commands. Okay. Right, I want conf t. I'll use the up arrow. Up arrow once, twice, 3 times, 4 times, there's conf t. Now I'm going to say VTP mode, just so you can see the different modes. You have server, transparent and client. The one we're interested on this switch is the server. On the server, when we create VLANs, it's going to send them down to the clients. You can't actually create VLANs on the clients manually from the command line. It won't let you. But it will allow the server to send information to the client and create VLANs. Okay, switch port mode server. Now that's the default. So it'll say it's already a server. There you go. We can create what's known as a VTP domain. So VTP domain, and then just give it a name. How about Cisco? Capital letters. Okay, so it's changing it from null, so no VTP domain, to VTP domain Cisco. Excellent. Okay, we could even put a password on. VTP password. I don't know. Bob. Okay, setting the VLAN database password to Bob. This would stop somebody coming in with a rogue switch and trying to sort of do dangerous things to your VLANs in your network. So we've got a VTP password on there. I'm going to do a Control Z and a WR. Now, let's have a little look at these switches. Switch 2. Conf T, speeding up a little bit now. VTP domain. Well, actually, let's just try something a minute. Show VTP status, which will show the VTP VLAN trunking protocol status. Hey, look at that. It's already got the VTP domain. Where did it get that from? It got it from the other switch. Went straight down the trunk link. Okay. I will put a VTP password on here. So VTP password. It probably got the VTP domain, actually. Wrong mode, conf t. VTP password Bob. It probably got the VTP domain because I hadn't even configured a pass. I've configured the domain before I configured the password, but let's have a little look. Okay, save that. Moving on to the third switch. Conf t. We'll put a VTP password Bob on that one, because I'm sure it's already got the VTP domain. So how did we see the VTP domain? It was show VTP status. There you go. What do you reckon you'd use to see the password? You probably guessed it. Show VTP password. That's not too bad, is it? Okay. Now, do we have any VLANs created? I'm on switch 3. Show VLAN brief. Yes, there are some VLANs. There's VLAN 1, 1002, 1003, 1004, and 1005. VLAN 1 is the default VLAN. All of the ports are currently in VLAN 1, except for Fast Ethernet 024. Why is Fast Ethernet 024 not in VLAN 1? It's because it's the trunk link. Yep. Trunk link, by definition, that carries all the VLANs. In fact, there is only one VLAN here at the moment. It's going to carry that one. These ones don't show up because these are special purpose. These belong to protocols which are no longer used on Ethernet switches. FDI, Fiber Distributed Data Interface, Token Ring, etc. So they're still there, but they're not actually used. So all of the ports, apart from the trunk links, end up in VLAN 1 by default. Okay, so we only have one VLAN. It's VLAN 1. I don't want to have to create all the VLANs on all the switches, but because we've got trunk links connecting the switches together, and we've set up VTP, I don't have to. I'll just go into the server, switch 1, I'll do conf t, and I'll start creating VLANs. So that's VLAN 10, and the name of that VLAN is sales. Exit. I'll use the up arrow to speed things up. VLAN 20. The name of that VLAN is research. Up arrow. Make use of the up arrow. VLAN 30. Name management. One more VLAN to do. Keep using that up arrow. Went a little bit too far that time. VLAN 40. Name. That says servers VLAN. Superb. Okay. And exit. I'll do a Control Z. Let's have a quick look at show VTP status. Show VTP status. Right. VTP status is telling us that we have 9 VLANs. Okay, I've only created 4, but we had the 5 default ones already, so that's where we get 9 from. The 5 default ones, the 4 I've created gives you the 9. Okay. Every time I created those VLANs, this little revision number here went up. The server with the highest revision number really takes control, which is where you have to be very careful, because if you have a server with a high revision number and somebody plugs it into a network and it just happens to trunk with your switches, if it's a higher revision number than your switches, then you can have big problems with VLANs being created on your switches, which you don't really want. Hence the VTP domains and passwords. Okay, so VTP, there's definitely plus and minus sides of it. Let's have a look at our VLANs. Show VLAN brief. And there they are. Okay, we've created 4 VLANs. There's the 5 existing VLANs, the defaults. There's the 9 VLANs in total. Currently no ports are in any of the VLANs. Let's check something though. I've not created any VLANs on this switch, but if VTP has worked correctly, they should have been created for me. And there they are. Notice VTP has replicated the VLANs across the trunk link from the server to the client. Let's see if the other client's got them. Show VLAN brief. And it has. What it hasn't done is it's not put the ports in though. The ports have to be associated with the correct VLAN. So, looking at the first switch, we've got VLAN 10 sales. Let's just drop the ports in. So, conf T. We can do a lot of ports at once. We're using the interface range command. Interface range. And I will put, the first 20 ports into VLAN 10. So FA 0 1 space hyphen space 20. That's the first 20 ports selected. And the way to put ports into a VLAN, you first have to tell the ports that they are access ports. So that's switch port mode access. Switch port mode access. You are an access port. Therefore, you are only supposed to be in one VLAN, at least one data VLAN. Switch port access VLAN 10. Done. Control Z, WR. That's that switch fully configured. Right, this switch is in which VLAN? VLAN 20. Okay, so conf T. We'll do the same thing. First 20 ports. Interface range, fast Ethernet 0, 1, space comma space 20. First thing, switch port mode access, you're an access port. Switch port access VLAN 20. The correct VLAN for the second switch is VLAN 20. Control Z, WR. And finally, third switch, which is in VLAN 30. Oh, actually, the third switch is in VLAN 30 and 40. We'll put the first 9 ports in VLAN 30. So interface range fast Ethernet 0, 1 to 9. First thing, let's tell it it's an access port. Switch port mode access. Switch port access VLAN 30, and we'll do an exit on there. Use the up arrow. Change it to fast Ethernet 010 to 20. Up arrow again. Switchport mode access, switchport access, VLAN 40. This is the server's VLAN. Okay, Control Z, WR. Let's just do a show VLAN brief. I'll use the up arrow. There it is, show VLAN brief. And now you can see that we've got 1 to 9 associated with the management VLAN, VLAN 30, and 10 to 20 associated with the server VLAN, VLAN 40. Which is correct, because that port there is fast Ethernet 10, 10 to 20 with the servers. That port there is fast Ethernet 01, 1 to 9 with the management. That's all done. Only remaining thing to do now is put subinterfaces onto the router, and yeah, we can do that now. It'll only take a couple of minutes. Click on the router. Subinterfaces will be the default gateways for the subnets that belong to those VLANs. Okay, so say no to initial configuration mode. Enable conf t. What's the first thing I want to do? Give it a host name, R1. I know where I am now. I will need to go into the physical interface connected to the switch, which is fast Ethernet 00, and I will type no IP address, just to make sure there's no IP address on it, and I will type no shutdown to bring it up. You'll notice the light's gone green. The light on the other side is still orange because spanning trees making sure there's no loops. When spanning tree says everything's okay, that light will go green as well. Okay. I'm going to exit from the physical interface because what I want to do is I want to create 4 subinterfaces now. Interface fast Ethernet 00.10. This will be subinterface number 10, 00.10. Okay, that's not a real interface, that's a logical interface, it doesn't really exist. What I'm going to do now, I'm going to type encapsulation .1q 10. In other words, look for frames tagged with a VLAN tag of 10, and I'll type the IP address. Now the IP address I'm going to use for VLAN 10 is the 172.16.10.0 network with a /24 mask. That means the highest usable address on this network will be 172.16.10.254. 255 would be the broadcast. So I will use the highest usable address for the default gateway for VLAN 10. So here we go. 172.16.10.254, and a /24 mask is 255.255.255.0. Done. I will exit that subinterface and now make quick use of the up arrow. Fast Ethernet 0020, next subinterface, up arrow, encapsulation.1q20, look for frames tagged with VLAN 20. IP address, okay, this will be the VLAN 20 subnet, 172.16.11.0/26. /26 means it goes up as a block of 64. 63 would be the broadcast, 62 would be the highest usable address. Okay, 62, and it's using a /26 subnet mask, which is 255.255.255.192. Wow. That didn't work. Why? Because I forgot to change the third octet. It's 172.16.11.62, not 10.62, because 10.62 would be in this first VLAN 10 subnet. Right. Exit. 30. Encapsulation .1q 30. IP address. Well, it is a /27 mask, so I'll do that bit first. 224. And what have we got? Starts at 64. /27 mask means it will go up in 32s. 64 and 32 and 96. 95 would be the broadcast. 94 would be the highest usable IP address. Amazing stuff, isn't it, subnetting? Exit. Right. 00.40. Encapsulation.1Q40. Server subnet. Ooh, now I'm going to have to move it across a bit to see what we're doing. 96 with a /28. What's a /28? That would be .240. And we've got a network that starts at 96. It's got a /28, which means it goes up in 16s. 96 and 16 is 112. 111 would be the broadcast. 110 would be the highest usable address. Excellent. Control Z and WR. Show IP interface brief. Can be shortened to show IP int br. And you can see that we have our 4 subinterfaces for the 4 VLANs. Each subinterface is the highest usable IP address in the VLAN. Therefore, these will be used as their default gateways because we're going to use the highest IP address as their default gateways. Fantastic. Right. Next video, we need to look at IP addressing. And what we're going to do is we're going to look at static IP addresses and DHCP. And this will allow us to get some pinging going on. Pinging using ICMP, Internet Control Message Protocol, to test connectivity. Well, I hope you enjoyed that video. I hope you found it useful. And tune in for Lab 3 when we look at IP addressing and interfaces. Thank you very much.